Hello, and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and professional development, serving a global membership of computing professionals and students. Hi, everyone. I'm Ankur Teredesai, co-founder and chief technology officer of Kensai and professor in computer science and systems at the University of Washington. My research spans data science with its applications for societal impact, particularly in healthcare. And I also serve as the executive director for the University of Washington Center for Data Science. I'm part of the ACM SIG KDD, Knowledge Discovery in Data Mining, and I'm the general co-chair for this year's ACM KDD conference, the leading organization for industry and academic researchers in data science. I'm also proud to be an ACM member. For more background, please check out my bio window on your screen. For those who are unfamiliar with ACM or what it has to offer, here is more information. ACM is the world's largest scientific and educational computing community. ACM offers educational and professional development resources that bolster the skills and enhance career opportunities for all. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see some of the highlights of ACM on your screen now. Before we get started, I'd like to quickly mention a few housekeeping items shown on the slide in front of you. First, the slides will advance automatically throughout the event. On the bottom panel, you'll find a number for additional widgets and resources. If you are experiencing problems with the slides or audio, please press the F5 key in Windows, Command R if you are on a Mac, or refresh your browser on a mobile device. You can close and relaunch the presentation at any time to help you with these issues. To control volume, please adjust the master volume on your computer, of course. And if you have questions during the webinar, which we of course encourage, please try and type them up into the Q&A box at any time during the webinar and click the submit button. I'll organize with Grace as she speaks, and she'll reserve time at the end of the presentation to answer and address all of them. The session is being recorded and will be archived. You will receive an automatic email notification when it becomes available, and you can view it again at a later date. For other webcasts and updates on this, please visit the learning.acm.org website, and you'll find more information there. At the end of this presentation, you'll also be receiving a survey open on your screen. Please do take a moment to fill it out and help us improve our webinars. You may also open the link to the survey at any time from the resources window on your screen. You can use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions regarding this webinar using the hashtag #ACMLearning. We'll be watching for your tweets. We also have a new community discourse page to continue the discussion after this webcast, including questions that we may not be able to answer in the given time frame today. So with that, welcome everyone again. Today's presentation is designing an ML-minded product and a product-minded ML system by Grace Huang. Grace, welcome.
Thank you, Ankur.
Most welcome, Grace. Grace, prolific profile. You lead the discovery data science team at Pinterest. Your team collaborates with engineering and product teams to create a key machine learning products that power the search recommendation and visual discovery experience at Pinterest. Pinterest, as we all know, is a very popular product for information sharing. In the past, Grace, you have led a wide range of data science projects spanning recommendation systems, search, relevance technologies, and particularly algorithm development in genome sequencing, as well as cancer diagnostics. It is great to see that your passion lies in a space where algorithms meet real-world applications and product design. We are very fortunate to have you talk about product design issues in machine learning, which is increasingly becoming so complex and interesting for all of us who are practicing the world of shipping machine learning-driven products to the world. Grace holds a PhD in computational genomics from the joint CMU PIT program in computational biology. And Grace, very thankful to you for being an ACM member. So without further ado, Grace, please take it away and begin the webinar.
Thank you, Ankur. Just want to make sure you can see me okay. Can you see my screen?
It's just coming up.
Great.
Not
Can
yet.
you see it now? No?
Yep, it's up.
It's up. Okay,
Yeah.
fantastic. Well, so first of all, I'd like to thank Huang for inviting me and organizing this event, as well as ACM for hosting this. A lot of appreciations out to Ankur for moderating this and helping make this a success. So my name is Grace. I am very excited to be here today to be sharing a lot of my past experience in building machine learning products with the audience. So thank you for attending the webinar. The talk today really is meant for anyone who may have some exposure or theoretical knowledge to machine learning systems, but may not have as much experience in real-world machine learning systems. And the motivation really is that, I've seen a lot of students who has a lot of these very theoretical knowledge, but did not have the chance to really practice it in the real world. And there's a lot of nuances and considerations that really is not quite obvious until you start implementing it. And so this is meant for whether you're a product manager, an engineer, a scientist, or really anyone who's interested in getting your hands-on experience with machine learning. This is the webinar for you. So I'd like to start with a motivating example. So as Ankur mentioned, I've been working at Pinterest for a few years with some of the past machine learning product experience. I've noticed that folks often don't know where to start when they're building the first product. So let's take this really simple example. In Pinterest, we have what is called a home feed. So this is a feed of pins that are personalized just for users. And in order to do that, we need to have some way of narrowing down the universe of content that we can possibly provide to a user and order them in a way that might be appealing. And so this is what we call a personalized home feed. And sort of the first reaction for a lot of people, if you're thinking about how to build this product, would be perhaps you can build a ranking system, right? You can pick best of the best among a lot of the candidates you might have and order them that way. And perhaps the ordering will be based on some sort of scoring that is produced by a ranker. And so that is absolutely a great intuition, and that is really the way to go. And so sort of if you start thinking about how you might approach that, you might think that, okay, I will start with a supervised learning model. Maybe I will have some labels. I will have some positive label for positive engagements that we would like to encourage, that we think is associated with positive product interaction, and some negative label or negative engagements that we might not want to encourage or that we think might indicate a lack of engagement with the product. And so you can build a model that predict some sort of probability that the user will interact with a pin and then you can then sort all the pins you might have based on the score. And the score might take advantage of features that include information about the pin and information about the user. And so far, that's a pretty textbook type example. And so it's, you can pull out your favorite machine learning library. You can choose your favorite supervised learning method, build a training set, and then start building this model. And so it sort of looks like this, right? Like in a lot of the textbook that you might look like, there's some sort of data collection step. You might do some really fancy data gymnastics to engineer your feature, and then you train your model, you do your parameter selection, you evaluate it using your favorite measures, and then you make predictions. Perhaps you store your prediction somewhere, and you can make it available for serving at some time. And so this is a pretty simplistic view of a model. It absolutely works for a lot of scenarios. So it works for scenarios where you really only need to make a one-time inference. It works for scenarios where the cardinality of your feature space is quite low. And so you can pre-store all the combinations that you may possibly need and serve it in some manner such that it's just accessing an offline store of your prediction. But in the case of, for example, a ranker that personalizes your content online, this is not quite enough. And in fact, it looks more like this. So this is sort of a high-level view of what a production machine learning system might actually look like if you're actually putting this into a product where you are serving millions and millions of users with very, very low latency with a very large feature space. And so what I like to talk about today is really a few folds. I like to talk about some of these components. And in fact, before I even talk about the components, I would like to really pause for a second and talk about what you should consider before you jumping into a system like this. So this is so important. I would like to dedicate a whole slide to it, which is before you start anything, you should think about what the objective of your product should be. Given that the title of the talk is Designing a Machine Learning-Minded Product and a Product-Minded Machine Learning System, it's not necessarily the case that you will want to use machine learning for your product. And so really the first question is, does your product really need machine learning? A lot of time, you may not need the level of complexity that's involved with machine learning in order to build a really great product. And so that's the first question that you should really think and pause and perhaps stop right there. There might be really simple ways to solve a problem that gets you 90% or even 95% of the way there. In the case of the ranker, in the earliest days, Pinterest used a time order method to order pins, and that was a really fantastic way to order content for users. And in fact, to this day, that is still something that we use and rely heavily in addition to machine learning. The second thing you should consider is, have you done any research or opportunity sizing to really understand how much more gain you will get from the model compared to really simple heuristics? Again, this is a step that is often overlooked, but is so crucial to building a really good product. And this is often done by data scientists or analysts or really engineers that's working on the product to understand whether or not you will be getting the gain that is worth the extra complexity that comes with machine learning. The third thing you should consider is, can your goal be succinctly expressed well by an objective function? Again, this is often not necessarily the case, and being able to express and encode your objective function well is really important in creating a good model. Have you collected enough data and validate that they're correct? And finally, do you have a way to measure the performance of your machine learning product online? Both of these involve logging. And logging is this dreaded word that a lot of people don't want to think about. But if you don't have logging before you even start to think about a machine learning product, it will not be successful. You will need logging both for training data, and you will need logging for evaluation of your model. And so with that, assuming that you have gone through this checklist, I'd like to jump into sort of like the components that will go into a production machine learning system. I will focus on 3 areas of the system today. I will talk about data, I will talk about evaluation, and I will talk about what are the criteria for launch. What I will not focus on is the details of training and details of serving. I think that there's just a lot of wonderful resources out there on these 2 topics, and each of them deserves a whole webinar or many hours of webinar alone. And so I will not focus on these. I will talk about sort of like the peripherals and the science around a machine learning product that is absolutely crucial to make it successful. In the second part of the talk, I will talk about a few lessons learned from past experiences, having seen a lot of machine learning products being launched or failed. And so that's how I'm going to structure the talk today. So first, I'd like to talk about some considerations you may need for the data piece of machine learning. So the machine learning products are very different from a generic front-end product. It's very different because it's actually a live system. It injects data, and it's only as good as the data it's able to acquire and consume. And so data is absolutely critical, and maintaining a healthy data pipeline is the only way to ensure that your machine learning product will be healthy. And so in general, there is some sort of pipeline that is generating both of your training data, your test data, and really the data that you're going to use to make predictions later. There is some sort of step where you convert some subset of the data pipeline output into a training set or test set such that you can build a model later. And then there is also often some sort of step that converts subset of your data pipeline output into data that you might need when you're doing online prediction for your model. And so if we go back to the ranking example we mentioned, we might want to build a ranker that takes advantage of information about a pin, information about a user, and then have some sort of function on top of that to predict the probability that this pin, the user, will actually match well, right? So in this example, we might have text information, image information. We might have information about the person who pinned the product or the pin that describes everything we know about the pin. We might also have some sort of derived information after we have these very explicit raw data, right? So we might want to make some inference about what language the pin likely is, what gender affinity it might be, what sort of general information space it lies in if you have a catalog of different ideas. Similarly, on the user side, you will have some very explicit information that might be provided by the user. They might tell you about their demographic information if they're willing to. You might collect a lot of engagement data, which is really some sort of combinations of actions they've taken on your site in the past. It might be information that they explicitly or implicitly done and engaged with on certain parts of the components of your UI. And finally, you will have some sort of derived information that you can take from all the past actions they've done. And so this, again, might be some sort of interest graph or interest representation of what this user might have. It might have some sort of probability vector of different types of topics that they might engage in. And so with all these data, you will need to have a way to log, ingest, transform, process, and store them. And so there are really a lot of components that go into it. First of all, you need logging in order to record all of the engagements. And logging is tricky because a lot of front-end UIs can change over time. A lot of times there is not a very good coordination between front-end teams who make changes to the front-end components and logging will invariably break, versus the back-end team who is ingesting data that is coming from the logging that is often done by the front-end team. And this breakage can really break a back-end machine learning product. There's aggregation. So if you're making any sort of inference or aggregations of information, like information about the pin or information about the user, it will invariably be a very large and messy hairball of ETLs. And so these data pipelines, first of all, has a lot of dependencies, can break very easily. Also, if your data is huge, like Pinterest, there will actually be a very significant overhead and lag from the time that data is recorded to the time that data inference is done and aggregation is done. So that's something that you will have to think about in terms of whether or not you can deal with that level of latency. You will need to have really sophisticated ETL management libraries. Some people might use external libraries that's available from third-party libraries and services, and some bigger companies may have their own ETL management. But this will need to be sophisticated enough such that it will be able to automatically handle all of the inflow and outflow of the data with the right level of management and policies for what happens if data fail. You will need data validation to ensure that your logging is correct, to ensure that your data is not corrupt, and to ensure that you have the right range of data and that it fits your expectation. And finally, you will want a lot of monitoring alerts for the pipeline that you're building, such that you will not find out 3 days after your data has broken that your product has broken, which unfortunately is very, very common for a machine learning product.
So Grace, just a quick pause here.
Yes.
On the fascinating subject of ETL and data pipeline. Mm-hmm. We are getting a few questions on the ETL process that is typically followed in production, yes. Particularly with large data sets and large streaming feeds such as Pinterest. And particularly the question is around, are there any specific tools or any specific sort of design patterns that are popular that one can use today that are different from normal sort of database ETL tools?
Yes, that's a great question. So first of all, I will say a lot of smaller companies may rely on third-party resources. So, for example, AWS has a whole suite of ETL management system. And so if you are part of that ecosystem, or Google, or various other services, there's generally an ecosystem that you can take advantage of. Now, if you're big enough, and I want to stress that you have to be quite big for this to be worth your time. You may want to build your own ETL libraries, and this may take into additional considerations like privacy, like how you might want to separate your data, different access, and how different teams might want to change and modify the same ETL at the same time. And so I would say if you are at the scale where you get to the point where you need to build your own ETL libraries, it is quite important to consider data governance, specifically who can create new pipelines, who can check in new data, and what are the criteria in which you will use to accept that. Because otherwise, very quickly, your ETL will become a very, very unmanageable mess of thousands or tens of thousands or even more processes that are constantly breaking without very clear dependencies.
Great. Thanks a lot, Grace.
Great.
Thanks a lot for that.
So the next set of considerations you may have is for training data. And, this is the area where a lot of people are quite familiar with in the very classical, offline batch machine learning models. In sort of like the more production environment, there's some additional considerations you might want to have. So, for example, if you have a lot of data Pinterest will be an example of that. We have too much engagement data. That's a blessing and a curse. We will need to have some sort of sampling in order for the training to be done efficiently. And so when you're sampling your data, there's really a lot of assumptions built in, and this will invariably control the output of your model. So for example, we can have a uniform sampling of all the engagements. That will produce a very different model than if we are to have a uniform sampling of users who may have varying amount of engagement. In the second scenario, you may actually give users who may not engage as much a little bit more weight implicitly. And so sampling is actually really quite important and is worth a lot of time to think of, to think about carefully and design carefully. The second thing you will want to think about is version control of your data. If you are constantly retraining your data, your model, you're constantly trying different variations of the model, version control is just as important as the code itself. And so you want to have proper version controls and be able to keep track of it easily, as well as code changes easily, and be able to evaluate your model in online or offline manner according to the versions you have. You will want to make sure that you monitor your feature distribution changes closely. In a live product like Pinterest, our demographics is constantly shifting as we expand internationally. Seasonality can kick in and create very large fluctuations in your feature distributions. Very different types of users might be using the product at different times of the day, different times of the week, and so on. And so depending on when you're collecting your data, your output can be drastically different. And so you want to take that into account and understand how you can account for it and understand what sort of average drifts you might expect and have alerts when that drift is larger than you would expect. Obviously, there are a lot of feature extractions and transformations you can done. I will not go into details of that. And again, you want to validate your feature value to make sure that they're actually in a range that is reasonable and are not missing. And finally, I think this is something that might be of interest to a lot of people, which is if you have multiple teams that are working on either the same or different machine learning models, invariably you're going to start using the same feature. In the case of the ranker, you will probably have a lot of teams that all need to use information about derived user interest. You may have a lot of teams that need to use information about derived pin information. And so the questions start to arise in terms of whether or not you should store your feature in a central place for everyone to access versus have everyone build their own pipeline in favor of agility. This is obviously a trade-off between better data governance when it's stored the same place, when you trade off speed versus when you enable all the teams to move really fast and build their own pipelines, but something that will create a technical debt that you will probably regret in a few months or a couple of years timeline. And so depending on how long the product is, how big the scale of the company is, and sort of whether or not you're at the first version of your iteration versus the 10th, the 15th, the 50th iteration of the data, you want to make sure that you're considering this trade-off properly. Now, when you're looking at the training data, it's actually going to be quite different from the data that's arriving on which you will make predictions later on for a system like Pinterest. So if your training data, it was created from 2 weeks ago on Christmas Day, you might actually have very different user demographics 2 weeks later, sometime in January. And so you want to make sure that you can account for this difference properly. And there are various ways to do that, but the first thing to think about, obviously, is to make sure that you have the right sample or combination of the date range or data range such that the distributions between your training set and your online prediction set is not too far from each other. There is often a lag to certain features being populated. So, for example, if you're calculating the derived user interest, it might rely on something like 50 or 100 different data pipelines in order for that computing to be done. And if you have a lot of data, that computation can take hours or sometimes even up to a day for it to finish. And so if there's a lag, that means that if you have online data arriving, it will probably not have access to that derived information right away. And so that creates a gap or a discrepancy between what you might have in your training data versus what you have in your online data, where that value will be missing. And that can create really terrible predictions when you have that gap between them. And so you want to either account for that and avoid features that is way too complex such that you will have a significant delay, or make sure that you have an elegant way of handling it either within the model itself with some sort of encoded information, or afterwards using some sort of policy layer or heuristics to counterbalance that. You might have logging change that you need to account for. Your ETLs might break. And again, your seasonality might change. And there might be market differences over time, or market differences between what you use as your training set and your online prediction set. And so all these are really something that you need to think very carefully about and make sure that your model can handle the discrepancies between your training set and your prediction set. Now, after that, we do our training. We serve it using pretty sophisticated infrastructure, and I'm going to jump right into the evaluation step. So again, in sort of like very traditional offline models, you evaluate using your favorite offline performance measures, and I won't go into details of that. But really, in a live product, there are a lot of other ways to do offline evaluation before you go on to experiments. And the reason why you might want to do this is, you might have a lot of engineers working on the product at the same time, so you may not have enough traffic to be able to do all the experiments you possibly want to do. B, your experiments might go tragically wrong, and that might cost you, user retention, and it could be very costly. And so you want to make sure that you have enough offline evaluations to get you to a place where you feel quite confident that your model is not going to be a catastrophic failure. And so human evaluation is something that folks often do. There are third-party services or in-house services that people might use to evaluate the output of the data. Yes.
Just a quick question. Could you give an example of offline performance evaluation experiment?
Yeah.
That might help the audience understand and appreciate the importance of this aspect of ML pipelines,
Yeah, absolutely. So in sort of like those very standard machine learning practices, folks often look at some sort of accuracy or some sort of precision recall that measures how much loss you're deriving from your model, right? So it could be AUC, it could be F1 score, a lot of very sophisticated methods to do that. And what that does is it gives you a sense of what your predictions, what sort of level of accuracy your predictions might get you, such that you have a rough sense of whether or not your model is really doing a lot better or just about the same as random. Does that answer your question?
Yes, Grace. I was looking for more of a sort of a practical example that Pinterest faces when deciding this, but that's in the ballpark.
Yes. So Pinterest uses a number of the pretty classical offline evaluation measures. But as I mentioned, we do also rely quite heavily on human evaluation and additional custom tools to help us understand whether or not the model is actually creating output that is expected. And so we use a combinations of sort of like classic computations of accuracy to help us understand whether the model is doing what we're expecting it to do, and additional tools that really help us contextualize and understand what the model is actually doing. And so, the custom tools that we have available might be something like you have a side-by-side tool where you can look at model A output, model B output by eye. And while that's not scalable, often that creates very rich hypotheses and understanding of what the model might be doing when it's moving a metric up or down in a certain way that might be counterintuitive. We might have some simulations of if we were to use these data, this is what we might see for this type of users like males, or we might see this sort of information for international users. And often that is quite useful for us to understand and gain an intuition hypothesis for what else we might want to test.
Great. Thanks a lot, Grace.
Great.
That addresses the question.
Great. So once you've done sort of like the offline check, you can now think about moving online, which is, like very classic A/B experimentation. And this is where a lot of people would start thinking about having a dashboard with metrics that you look at to help you understand whether or not your model is creating an output that is better or worse than your existing model. And so there are actually a lot of interesting and subtle points in how you should think about your metrics. Often you do not have a single goal metric. Often you have a suite of metrics that you really care about. In our case, obviously the very long-term goal that we care about is user satisfaction. And we think that one way to understand that is measured by user retention, right? Whether or not people come back. And so really that is the goal metric we're trying to get at. However, in the span of an experiment, we often do not run experiments long enough to be able to see that very long-term retention pattern. So we can really only have a window into a shorter time span in which this happens. And so in order for us to assess a model, we really need to rely on things like leading indicators that we think might correlate with long-term retention. And so leading indicators might be things like how much you engage with the site. Does that increase certain B group compared to A group, how much you come back in a day, come back within a few weeks, and so on, to help us understand what you might do in the long term. And tying leading indicators to long-term goal metric is really deserves some research and careful thinking itself. You will probably also want to have a lot of debug metrics to help you understand if you see a drop or increase of goal metric or leading indicator, why might it be? Often it might not actually be caused by the model itself, but rather artifacts of the model. Perhaps it is the data distribution change. Perhaps you invariably break a part of the components to push out a new model. This happens all the time. And so debug metrics are very useful for you to understand, contextualize why your metrics are changing. You probably want to have some sort of guardrail metrics placed around things that you care about but are not explicitly optimizing toward. And so, for example, in the case of a ranker, we might want to make sure that our content is still fresh enough, even if we optimize for some sort of engagement. Or we might want to make sure that our content is within some safety criteria or misinformation criteria such that even if we optimize for engagement, we are not sending spam to our users. We're not sending unsafe content or porn to our users. And so guardrail metrics are really important to ensure that your product is within a range of acceptable behavior. And finally, you want to have a lot of custom tools to help you understand these metrics. And one last point I want to make here is that metrics is not the same as loss function. It's very tempting, if you're an engineer, for you to decide that the goal metric you will use is a loss function that you're encoding, because obviously if you optimize for your loss function, you will optimize your metric, but it is really not the case. So I want to stress that this is something that you have to think about carefully. And finally, we want to make sure that when we launch a product, there are a lot of careful considerations for what goes into the launching decision. So obviously you want to look at the metrics from the evaluation step. But you also want to think about infrastructure costs. Is it worth the extra memory, the extra machines that you're pushing when you, let's say, switch over to a deep learning model or a very sophisticated model that takes a lot of resources? Is it worth the extra future maintenance overhead? I like to think of this as a way of regularization as well, in a parallel to sort of like the classical regularization concept. If you create a more sophisticated model, if you use more features, you're invariably going to have more overhead in the future in terms of engineering hours to maintain and fix these extra complexities that you're introducing to a system. So is the gain really worth that extra overhead? That's something to think about. it's very important that your shipping decision is guided by product vision. A lot of time, you may increase the engagement metric or goal metric, but create a product that really directly go against a product vision. For example, in the case where you exploit engagement to the point where you're sending a lot of spam pins and showing them to users, right? So product vision really at the end of the day should be something that is part of your design and part of your consideration. And sometimes it can trump information like metrics. One thing that's very interesting to consider is if you have a product where you have a very limited real estate, like let's say you have just a phone app, you have a small amount of real estate on the phone at any given time, but let's say there are 7 or 8 or 20 different features on that same space. Often they're competing for the user's attention. And so if you have 7 or 10 different teams working on different features, each with their own machine learning product, invariably they're going to start stepping onto each other's toes. And so this is where cannibalization can happen. You can really increase your metrics in one product feature on the part of your screen, let's say your home feed, but then really hurt another feature, let's say search feature on your app. And so while you can single-handedly optimize for a single feature on your product, you want to make sure that together all these different features are creating a coherent product that is actually conducive to your users returning and using it in a very satisfying manner. And finally, the last thing you should think about is speed versus iteration. So you can never be too careful with your models. Sometimes you might want to have 10, 20 iterations or more just to learn from your users. However, your speed might suffer. And so there's always this tension between these two. So again, depending on the scale of your company and where you are in your product stage, you want to make sure that sometimes you favor speed, but sometimes you favor really careful iteration, especially toward the end as your product is more mature and your model has been iterated on for a few cycles. So lastly, once you shipped it, you want to continue to monitor your product. And so there are a number of factors you should consider. You should make sure that your goal metrics is on a dashboard somewhere that you can look at. You want to have some sort of alerts for your distribution drifts. And then inevitably, your product is going to break at some point. And there's going to be a metric fire drill, and you're going to have investigations into why that's happening. And so when you get to a certain scale, you want to make sure you have runbooks and tools and delegations to make sure that you have a way to handle these investigations. And finally, if you have a system that's complex, you need to have automation. So automation is key. There's automation in every single one of these steps that you will want to eventually get to. This is probably not something you should think about if you are just starting out. But eventually you want to think about doing these so that you're not caught in the cycle of constantly fixing and manually pushing models, deploying it, testing it, and evaluating it. However, in the last step, right before launch, there should always be a human touch. There should always be a human component to make sure that the product you're creating is actually something that is consistent with the product vision that you have. And so with that, I would like to move on to the second part of my talk, which is a few lessons learned in building and having seen a lot of machine learning products in the past. The first thing I'd like to talk about is really data and system bias. So here's an example of a sink on the left where might just be what you expect what a sink looks like versus on the right, that's probably what you will see if you come to Pinterest and search for a sink. And so the one on the right will absolutely get a lot of engagement on Pinterest. It feels more Pinteresty. And so if we use engagement data from Pinterest, we will probably rank the pin on the right higher than the pin on the left. And that's fantastic for Pinterest. However, it could hurt us in a way as well. So if you type the word football on the left, might be what you find on a more traditional search engine. And depending on where you are, you might have 2 different kinds of football. Versus on the right, that might be what you find on Pinterest if you only use engagement data to rank your product. And why is that? Well, it turned out a lot of Pinterest users really love food. And so there's a lot of engagement with these type of football food pins. And so engagement data is something that you should think carefully about because it can introduce pre-existing bias of your users and your system. And so this is a pretty active area of research. There are a lot of papers on these. You want to make sure that rich doesn't get richer in the sense that users who already engage with your data are not continuing to benefit from that at the expense of users who maybe are new to your platform, but you want to make sure that you include them in the future. This is important if you're moving to new markets, let's say expanding internationally. This is important as you want to expand beyond your core user demographic. And so there's something to think about. And in lieu of recent events, there's also a lot of active discussions around fairness, right? So how can you make sure that you design a system that is fair and does not encode human pre-existing bias into your system? And so this is something that I think is something that's worth considering for everyone.
So
Testing,
Grace, quick question on this. This is a very important topic for the entire, AI machine learning community.
Right.
And generally, bias in the machine learning models is something that we are all actively exploring. Now,
yes.
the question that I have, and many of the listeners today have, is there something that product designers and ML pipeline, as a product, can put in so that these type of biases don't creep in? So there is this experimentation and sort of solving the problem from a research perspective, but is there something that we can do from a product design perspective? And are
Absolutely.
there any best lessons?
Absolutely. That's a really fantastic question. So I think that there are a lot of things you can do on the front end part, and I will not go into that as I'm not an expert in that area. But as you're thinking about your machine learning system, you want to make sure that your data is sampled in a way that is reflective of where you want your product to be, not where your product is today. And so, for example, if you want to make sure that your product is not encoding perhaps some sort of hate speech or some sort of bias in your users' opinions, you will want to make sure you look at the distributions of data to ensure that effect is removed, right? So, for example, if a pin that represents content that you do not think should be part of your content in your platform, you can downsample it. You can change the weight of your objective function. You can explicitly encode it such that that is being punished in your system. And finally, you could have heuristics and policy layer after your ranker, after your machine learning model to make sure that is either counteracted or removed from your system. And so there are ways to encode that vision into your system, and it sort of depends on how harsh you want that penalty is, whether or not it's a filtering step versus a demotion step. And that will depend on the product you have. Does that answer the question?
So yes, it does, Grace. So just to summarize, you're saying that one has to be careful about this issue when designing the objective function. One has to be careful about this issue when sampling the training data set to then produce the model. And one has to be careful about this issue and put in testing scripts in place when we have a loss function evaluation to then put the right model into production so that it is aware of these inherent biases and it is addressed before the fact, right?
Yes,
so
absolutely.
Absolutely. Makes sense. Makes complete sense.
Great. Right. So the second lesson learned is that you absolutely should be doing testing and monitoring. So this is sort of a cautionary tale. In the past, we have seen an incident where we saw a metric that we really care about decline all of a sudden over some time frame. And as we investigated, it turned out that it was a migration to a neural network from a tree model that we have on this ranker that we talked about. And so everyone's scratching their head, right? Because, offline, we thought that neural network worked better. Why would this happen? Well, it turned out that it has nothing to do with the migration to neural network. It turned out that there was a data change even weeks before that migration. And that data change had caused some data values to change significantly and it was actually a data fix. It was actually something that was good. But what happened with a tree model was that in the past, a tree model was masking the effect of the data change because it's not as sensitive to outlier data ranges or missing values, versus when you move to a neural network, you all of a sudden become very sensitive to those feature values, and that can shift your data and your model significantly. And so that's actually a really, really tricky investigation because the drop did not happen at the time when that data change happened. And that really was a result of, sort of like not very careful data monitoring of distributions of the features that you're using or labels that you're using. And so there's something to keep in mind, that offline data distribution really is not the same as online data distribution. And as early as possible in your product development cycle, you want to make sure that this check is put in place such that it's done in an automatic way, so you have alerts for data coverage drop or corruptions. Let's say you're only logging 20% of all your data, or that you're all of a sudden getting a lot of missing value because the ETL pipeline breaks. Because these sort of failures are very silent. And it's not the sort of failure where you will get user complaints right away. It's something that you might see days or even weeks after you've had the failure. Next, we want to make sure that good infrastructure speeds up iteration, and this is especially important if you have a lot of engineers working on the same product as you scale. And so you want to make sure that they're automated training deploy pipelines so that a lot of the manual step can be removed and human error can be removed from the system as much as possible. When you have a lot of people working on the same product, you will probably have a lot of experiments run at the same time. If it's the same component, like if all of them are working on the ranker, they're going to have to share the traffic. And so you want to make sure that you have ways to divide your traffic efficiently so that people can ship multiple experiments at the same time without having interactions. And you want to make sure that that compartmentation is changed every once in a while so that users are not always in the same set of experiments or same type of experiments all the time. And you want to make sure that there are a lot of effective offline analysis tools to help you reduce the amount of live experiments that you need to run because of the constraints I mentioned. Fourth, you want to make sure that you have really, really good measurement and understandings. And so again, offline performance is really not the same as online performance. As we mentioned earlier, if you have an offline step of understanding which models might perform better, really at the end of the day, your live experiment should be the final bar. You should really make all of your final decisions based on what you see on the live experiment. And in fact, a lot of times you want to run experiments just to learn what happens if you tweak a parameter, what happens if you change a sampling distribution, or if you change a specific component. And so you want to invest in toolings to make sure that you can understand these type of changes. And this is especially important as you move toward more black boxy models. A lot of the deep learning models are very opaque. It's very difficult to understand what's happening. And so, you might want to use things like ablation experiments or additional analyses to help you understand what's really happening. And you also want to make sure that you understand long-term ecosystem effect. There are a lot of changes that may not be very obvious a day, a week, or even a month after you push, but it could affect your long-term data ecosystem. So, for example, if you are consistently favoring pins that are very popular, but may not be very fresh because you have a lot of information on them, that effect you may not see until several months or even a year later. And so you want to think ahead of that game to make sure that you account for that. And so this can often be summarized by sort of like the Goodhart's law, where you might want to make sure that when you have a measure that is invariably becoming a target for a lot of engineers, everyone will going to start to work toward optimizing it, right? So if some sort of engagement rate becomes a target that you're optimizing toward, everyone will be building their loss functions using that engagement rate. But really that engagement rate is just a leading indicator or representation of what long-term product vision might be, and it might not actually reflect what the long-term user satisfaction is. And so you should be very careful with what you're trying to go on and not to confuse that with what your long-term goal metrics should be that really at the end of the day represent where your product wants to be. And so
Great. So
Yes.
one question on that. So what happens in this type of situation where you launch the product with a model, and then that model starts to behave in a wrong way after launching? So this is a question on Twitter that just came in, and it's a very, very interesting question. So I thought I'll ask.
That's a great question. So it depends on what you mean by wrong. There are many ways of it being wrong. It could be wrong in the sense that the goal metric you see is not moving in a way that you thought is moving. And this might be caused by a lot of different things. It could be the offline-online data discrepancy that's worth investigating. It could be seasonality. It could be that you have a bug in your system, so you want to make sure that you have a way to audit every single output of your pipeline to make sure that each of them is exactly what you're expecting. And then sometimes, you will have output when you really just don't understand why that might be the case. And that's where you want to do a lot of analyses and research to really help you gain some insights into what the model is doing. If you have a system where you're continuously updating your model, let's say it's very sophisticated, you're continuously updating it or continuously retraining it, it might justify for, not investing as much time to understand it because, maybe you will continue to use new data and that will eventually take over. But if you have a model that is rather static, let's say you only update it every month or every week, it's really worth doing the research to understand what the output might be coming from.
Great. Thank you, Grace.
Great. So you want to make sure that you can handle co-stars very elegantly. This is something that, a lot of products will often see at the very beginning of the product cycle, right? So if you don't have much data, you obviously will have that problem. And there are ways of handling it by, for example, giving like the very classic like Netflix surveys and so on to collect information about user. But there are also other types of more nuanced co-stars that you should think about. So if you have a system like Pinterest where you constantly have content that's coming that's very fresh, because we don't have as much understanding about them, we will need to make sure that they're not just represented by missing values all the time, especially if you're depending on a data pipeline that takes a very long time to compute, right? And so you want to make sure that these fresh data either is getting some artificial boost or they're being encoded in a way such that they have some prior or smoothing parameter that is reflected in the feature value so that they have a fair chance of competing with other content. And the same thing with new users, right? Like there are ways of encoding that into your system such that you give them a fair chance of being surfaced or exploring the space of possible content they might want to look at. And so if you don't do that, it really can lead to quite catastrophic results where you might have very streaky content. You might even have offensive content showing up because those content might be older and have a lot of past engagement signal, which unfortunately will sometimes trump fresher and higher quality content. You want to make sure that you build a system with very tight negative feedback and make use of negative signals as much as possible. So you can build that into your objective function, for example. You might have labels that represent negative signals that you can collect, like someone have a dislike or a hide action, or you can ensure that you build it into your features so that you can add more features that help in predicting negative events that will capture what often correlates with someone not liking a content or not engaging with the content. The one thing I want to note is you want to make sure that you separate your spam and racy filtering from negative signal. Spam and racy is quite different in the sense that it's an adversarial system, so it's constantly changing. And so if you build it into your system, it becomes a game of cat and mouse with the spam content creators. And so that's something that you probably actually want to remove from your machine learning model and handle separately. And finally, I just want to mention again, if you want to build a machine learning-minded product and a product-minded machine learning system, the first thing you should consider is, do you really need machine learning? In the ranker example I mentioned, we actually started with heuristics, right? It was time ordering model. We moved to a relatively simple linear model. then a tree model, and then a neural net model. And so it actually turned out that it takes a very long time to migrate from one model to the next, because a simpler model might capture 80 or 90% of the gain you might have. And because it's being so fine-tuned and optimized, that it's actually really difficult to replace it with a newer, shinier, fancier model that hasn't been fine-tuned as much. And so there's a lot of cost and overhead in migrating to these more sophisticated models, or really going from heuristics to a model. And that's something that you should think carefully about as you implement. For a lot of complex problems, like improving the diversity of the content you show to users, or the freshness of content you show to users, you need a lot of components working together in order for that to work, right? So if you have a lot of candidate pins that you might show to a user, you want to make sure that the diversity and the freshness optimization is done all the way at the beginning of your candidate generation. Because if you only optimize it at the ranking stage, if you don't have fresh candidates to work with, or diverse candidates to work with, you're really only going to be limited by what you can see coming in. And so there are a lot of these bottleneck effects where if you have a very large company, large teams, each working on individual components, you want to make sure that bottlenecks are removed, or at least teams are aware of each other and communicating, working together for your product to be great. And finally, it's really important for you to have a way to build policy and production vision to a machine learning system. One simple way of doing that is really just have a policy layer right after your machine learning model, such that you can have additional heuristics that encode maybe freshness, maybe diversity, maybe safety policies into your products, so that it catches and represents the full product vision that you have. Last thing I want to talk about. Grace. Yes.
Since we are just closing in on our time today, so just wanted you to do a quick time check.
Great.
As you close out.
Great. Right. So just to quickly summarize, the one topic that's fascinating to a lot of people is exploration versus exploitation in your system. Won't go into details, but this is something to think about. You might want to separate these into different product features or different surfaces, as it's really difficult to evaluate exploration. And if you mix them together, it's going to almost always be a case where you favor exploitation over exploration if you only have a single goal metric. And finally, I want to say that you want to make sure you build a system for users tomorrow, for users you really care about, not users today, right? So if you have a lot of local US domestic users today, but you want to expand internationally, you want to make sure that you're looking at engagement of local content at, let's say, France, instead of engagement with English content. And so you want to make sure that that is building to, for example, your sampling scheme, your objective function, and your evaluation criteria. So with that, I'm going to close and answer any quick questions that the audience might have.
Thank you, Grace. As we were going along in the webinar today, we did answer quite a lot of questions that came in through the audience channel. I'm afraid we have run out of time today. I'd like to thank Grace again for her informative presentation and very insightful answers to building a machine learning product and building a product with machine learning in mind. And thanks for taking time to attend and participate, everyone, on the webinar. Jan, could you please push to your this recorded webinar will be available online in a few days at webinar.acm.org. If you find announcements on upcoming webinars as well over there, and at learning.acm.org. Please do fill out the survey where you can suggest future topics or speakers, and we will be surely getting in touch with them. Again, on behalf of ACM, Grace Huang, and myself, Ankur Desai, thanks again for joining us, and I hope you will join us again in the future. Thank you so much, and this concludes the webinar.
Thank you.